All right, everybody, welcome to Chapter 4. We are going to build off of what we learned in Chapter 3. So, Chapter 3 was all about systems of equations, and eventually in Chapter 4 you will see how they're connected. At first, though, matrices, or that's the plural form, a matrix is the singular form. These guys are a lot different from what we've seen in the past, but they have a lot of similarities to Chapter 3's system of equations, like I said. So there's some details that we got to know about matrices, how they're arranged, what they look like, how to interpret different parts of them. But first, what I'd like for you to do is get a few definitions down. You've got the word matrix right here, and it says the rectangular grid of variables or numbers. And so I've got a rectangular grid, and you usually have them with those brackets that have kind of the enclosed space on the top. And I'm not saying that you have to have variables on top or numbers on the bottom. They can be mixed and matched. They might be all variables. They might be all numbers. So they come in different ways. Next, an element. What each value in a matrix is called. So the element in the first location for the matrix above is just the x. The element down here is the 2. And we'll talk about how to identify these elements here in a little bit. So probably the most important, fundamental, basic idea of a matrix is its dimensions. How many rows and how many columns does it have? So if I talk about, vaguely, generally, m rows and n columns, I'm going to talk about it as an m by n. That x, think about it like in construction terms or architect, when you have kind of like the 2 by 4. When we see the x, think of the word by, m by n. So that's why I write that. So with words, we might have 3 rows and 4 columns. Not words, numbers, sorry. And that would be 3 by 4. And that's how you see that. So 3 rows and 4 columns. So rows, then columns. It's kind of easy to remember x, y, because our rows go across and our columns go up and down. So think of it that way maybe. Here's an example. I didn't fill it in with anything special, just blanks. But you can see how there's 3 rows, the first one, second one, and third one. And you have 4 columns. 1, 2, 3, 4, up and down. Alright? So when we look at a situation of a matrix called A, sometimes they're always labeled as, they might have a word or a name, but they also might just be given a capital letter. So the capital letter A matrix is 1x, y2, z3. What is the value of A21? Well, first of all, let's talk about what are the dimensions of this matrix A? How many rows do you see? You should see a row that begins with a 1, a y, and a z. So 1, 2, 3 rows, and you should see 2 columns. The first one and the second one. So 3 by 2, 3x2, 3 by 2. Alright, so when we answer the question, it says that the lowercase a in the question means to refer to the big A matrix. Pretty easy. The 21 means row 2 and column 1. So they don't put the x here, they just put 2, 1. So when we look at row 2, that's the y and 2. And we look at the column 1, we notice that the y is actually in that location. So the answer for the value of A21 is y for that matrix. All right. For example, what if we said 12, element A12? We would think about row 1 and column 2, so that would be the x. An element that would not show up on this matrix would be something like element 32. So we would go over, 32 would actually show up. Sorry. What if we said 34? Go down to the 3rd row, and then the 3rd and 4th column is not there. So we won't have an element 34. The largest element we have would be 32, and the smallest we have is 11. Row 1, column 1. Row 3, column 2. So we'll talk about that in class if you have any issues. In red right here, you see that it says matrices that are equal must have the same dimensions. So we can actually put two matrices together, put an equal sign between them. But if they don't look like they're the same matrix in dimensions senses, then they can't be equal. So for this matrix A to be equal to another matrix, you would have to see another one that had 6 elements total with 3 rows and 2 columns. So we would have to investigate that. Now a question you might get on your state test or even on your homework is down here at the bottom. Take a set of data and put it into a matrix form. So I think we've got a bowling situation. You've got John, Hideo, and Paulo, and they all bowled 3 games, and then they have their series total. Now, if you can't see the numbers that great, that's okay. The idea is much more important. What we want to do with a matrix, we want to skin it of everything that's not necessary, and that would be everything but the numbers. So in your answer down here in the bottom right, it might be tough to see the numbers. You have the 221, 168, 187 in the first column, and you have the second column, third column, and fourth column. So we have just the numbers. We do not care about the categories. And so when we rewrite this, you know that this is John's results on the top, and Hideo in the middle, and Paulo in the third. And you also know that this is game 1, game 2, game 3, and the series total. So you would be able to interpret that because you have the original information right there. So dimensions are super important. Please make sure you understand dimensions. Look it up in the book. Look for other examples. And if you have any questions, bring them on in the class. This is 4.1 very quickly. And always remember, flip, don't flop.